that you can use. So we are happy today and this afternoon to welcome Dr. Mara Abel, who is a geologist and doctor in computer science. She's developing research on knowledge engineering applied to petroleum industry. She was, let's say, in the last decades, she was dedicated to knowledge management, to knowledge engineering research for building ontologies applied to petroleum geology and also the entrepreneurship development. She's co-founder of the knowledge-based software company and Deeper, and she has conceived several successful applications for reservoir characterization. She had coordinated dozens of national and international large knowledge management and engineering projects, as the citizen portal for Angola government, sponsored by World Bank and several research cooperation projects. Also, she is leading the Brazilian side of the Norway Brazil PET Win project for defining the semantic framework for a digital twin in petroleum production monitoring and optimization. So, welcome, Mara, and I give you the floor to present your talk.
Thank you very much for the introduction. Happy to be here, very honored to be invited to present this. I will share with you my experience in the last decades developing petroleum industrial projects related to ontology, knowledge management, and semantic in general. So our agenda is like this: explain why petroleum companies invest so much in research on semantic and ontology, why ontology in these domains, indeed, what ontology is trying to solve and to support tasks in this domain. I will explain a little about the general approach that we use in our several projects, and then introduce you to some large projects that we have developed in exploration area, reservoir, and production area. And finally, I will show you the ongoing projects in my group and explain the methodology that we are using for developing and apply ontology. So that's the general agenda. So petroleum industry has some particular characteristics related to other types of industry. Is an industry that is old. They are the same. Few companies work for a century, and they are all the time trying to be in the state of art on research and scientific development. And nowadays they are evolving very quickly to a full industry 4.0. So integration of data and data analysis, and the extraction of information using data mining and machine learning became a very important issue more and more in this industry. And especially since they are in the frontier of scientific development, they are indeed a very, very knowledge intensive company. So most of software and software framework that they apply are very knowledge intensive. And this requires a lot about semantic techniques to be developed. One strong characteristic is the sophistication of the application requires special companies to support the applications. And then the industry itself is supported by a multiplicity of software providers that try and have been developed information silos. which means they have solution for a bunch of data or some applications or some particular problem inside of the industry, and they try to keep the data processed by their own application. And in the last decade, the last years, the petroleum industry is trying hard to avoid these niche formation and adopt standards that can be larger used and transform the companies became more independent of the providers and suppliers. So the use of standards and the interoperability of data became a very, very important issue inside of the company. And ontology is an answer for them. So we work exactly on this issue, interoperability, data interoperability inside of the whole exploration and production chain in petroleum industry. The problem is basically this. We have several types of activities. Activities are knowledge intensive, very different. We have geologists, we have engineers, reservoir engineers, you have chemistry people, and for each of these applications, for each of these activities, we have applications that materialize the view and the conceptualization of each community to produce data models, and these data models are materialized in software applications, which are very sophisticated. So the problem is that when you have that, each of these systems is still indeed have their own view over the data. And when you need to exchange the data, you have a common view over this data, to integrate the data, to cross-correlate the data. You have a lot of problems related to semantic, because the concepts, the entity that are manipulated by these models and applications sometimes has the same name, but they are not conceptually the same entity. So that's the answer, that's the question that ontologists try to answer in this industry. So what we do indeed is try to make explicit the semantic of the entities involved in the software applications or in the tasks, because sometimes the problem is not exactly running a software, but sometimes the problem is communication indeed between teams of different specialization area. So what ontology do is to offer a uniform view over the data. And we do this identifying rigid entity, rigid in the sense of entity that provides their ontological identity, and make explicit the meaning of this entity, and use this entity to anchor models, which means we identify the same entity on the domain, like this Christmas tree, which is a pump as installation for extracting petroleum for the under the surface, and then we take this entity and map this entity among the several conceptual models, trying to make evidence the data that can be integrated or not. So basically, the ontological analysis, what does is to analyze the models, the documentations, identify entities that are presenting several different conceptual models of applications or documentation, make explicit the meaning of this entity, and use this entity to map from one model to other. And then these supported by applications. So our general approach in our project is like this, is to have a layer of data repository, persistence of data, which is non-proprietary data. Sometimes it's proprietary data, but our aim now is to use standard models and formats to store the data and to interchange the data. But even when we use standard formats like HASCML or the ISO and CIFUS and many other standards in petroleum industry, the only standard is not integrable because they have their own semantic. But at least we try to produce persistency of the data in non-proprietary formats, and then we run the application over this data, independent application for several providers, and do the communication of the application with the data through a domain ontology. So what we do is to produce this domain ontology and let the application to use it to do consultation over the data or integration over the data or even for documentation of the data. That's the general approach of all the projects. So with this general view, I will show you some of our the bigger project. We have several small applications, but this will be the bigger for you to have an idea about what we have done. So all of this is in the petroleum industry, mostly is in exploration, since I am a geologist and have my formation on petroleum geology for many time ago. Then the applications mostly are in exploration, but nowadays we are also working with production, reservoir and production area. So the first big application was the result of my PhD project, which has the first version in 2000, which is the Petrol Edge project. Petrol Edge is a suite of several applications for reservoir characterization that has after that expanded to deal with petrographic description for any kinds of rocks. So Petrol Edge, what Petrol Edge done is to model in an ontology the full terminology of petrographic description of siliciclastic and pre-salt, which is carbonate rocks, is around 2,000 terms that is formalized, and then the system helps in provide the detailed diagenetic characterization, which is the properties that define the quality of the reservoir, the porosity and permeability of the reservoir. Then we develop an application for support description, and over this description data, we have done a lot of automatic interpretation applying geological methods. So the diagenetic environment, the rock classification, and producing automatic report, and several applications that are running geochemistry analysis and things like this. It's a project that was supported by public funding in Brazil, CNPq, FINEP, FAPERGS, and then the result of this is the creation of a deeper company that after that is being supported the group, with funding also the group. So that was our first suite of applications, and is using also for image label and retrieval. So we use the term to describe the reservoir image, and then we can do recover over any kind of characteristic of the rock to do geological interpretation. So this is an application of this suite of Petrol Edge also. Then Petrol Edge works in microscopic scale, and then we move to core scale, which is the hand sample size of description, and we produce 1,000 formalized sedimentological terms associated to icons to help the description. We develop an application for tablet and desktop for describing these rocks and cores. And then over this data also we produce a lot of data analytic and export report and cross correlation, a set of applications using that concepts that you have the ontology, that let you to integrate the data along with external data that comes from other applications. More recently, Lua Garcia has produced his doctoral thesis in producing a Geocarontology, which is a top-level ontology, or medium-level ontology would be the right term, that defines the most common and high-level terminology in geology domain. So considers what is the more important and present entities in the geology domain, which is the rock of the body of rock, the rock itself, and the geological structure, the relation, the contacts with the body. So most of the important terms were defined, and from this term we can specialize petroleum geology in subdomains like stratigraphy, geochemistry, and things like this can be specialized. The geocarontology was defined after BFO, that is used as a framework, and then we derive BFO to produce these terms, and we use Corontology, GeoCor, to develop the ontologies in several applications in geology using ontology. Using GeoCor, and more recently, we developed a project which is called the GeoDigital project, with the main intention is to do information retrieval over technical documentation inside of Petrobras. So this project, what he does is to explore information retrieval techniques and machine learning, and also ontology to help in drive the user to the search of information. So ontology formalize the terminology, the vocabulary, and we use information retrieval to index and retrieving the information. One of the very interesting results of this project is an ontology for exploration and reserve that is support the description and the interpretation and mostly technical reports of petroleum exploration activity. So we developed this ontology based on the BFO and also the information artifact ontology, but we define, I hope, most or all the terminology that is used to denominate figures in exploration. So maps, graphs, geological section, seismic cubes and seismic section. And we use this to label the image and then to support machine learning application. So we collect 27,000 figures in exploration, petroleum exploration. We classify, we label and classify these 27,000 figures, and we training a machine learning figure classification that can reach for more important kinds of images. We can reach around 85 to 95% of correct classification of image. So what the result of the project basically is scan over the reports and documentation, papers and technical report, mostly index these both the text and the image, and then the system use this to classify and recover the information that is in technical report. We finished this project in July this year. So this is an ongoing project. We are completing the first year of a 3-year project, which is the Georeservoir project for the description and searching and data analytic of sedimentary deposit, deep sea sedimentary deposits, mostly turbidites, which is the main kind of reservoir type of rock in Brazil and North Sea and coast of Africa. The most frequent kind of reservoir in these places is turbidites. Then we develop a full ontology to describe geometry and architecture and kinds of rocks and sedimentary structure. And then we are intend to use this for automatic detection of analogs. The idea of the project is that when you start a new play of study in an exploration area, you don't have direct access to the data, and then you use the data that you have and try to recover similar deposits that has petroleum occurrence or not, and using the data of this similar occurrence, geological occurrence, to get some new insights for this new player. So we have a team that is working with ontology, developing ontology, and also developing geometric simulation of the architecture and geometry of these deposits. This project, we have 2 more years of development. And then our bigger project and very ambitious the Oslo University of Norway, and along with FINEP, which is our public funding in Brazil, and Total, and Sinop, Petrobras, CNC, and Shell, and Equinor. So the general idea of PET twin is to get the physical installation of a plant production of petroleum, and then we produce a virtual representation of this physical installation to support data analytic and real-time monitoring to optimize petroleum production. So that's the general idea of the project, and we have many aspects of this project. We deal with cloud, with the data storage, but I will emphasize here the methodology for the semantic treatment. So how do we collect this giant set of terms and model it to produce an ontology? We are also in the first year of a 4-year project. Then we have 3 years in front of us for this development. So we start with requirement capture to understand what is a digital twin and what they wait and expect for a digital twin. Then, using the documentation and interview, we do terminology extraction, and then ontological analysis, and then ontological specification in an artifact to be processed, and then we support data analytic. So just a little of detail on this. We start with focus group efforts. So 2 days workshop with the whole team of managers of Libra Consortium, which is the company that groups Petrobras, CNC, and Total and Shell in Brazil, and Petrobras also. The staff of Petrobras. Then we have 2 days workshop to discuss about this requirement, and then Libra, the staff of Libra, indicate 6 of main petroleum areas and indicate 14 technical people to support our project. Then the area is topside, subsea, well, reservoir, artificial lift and flow assurance, and the integration operation center. Then with these groups, we separate for each area, and we develop 8 sections of 2 hours with the technical staff for each area, so subgroups. And then the moderators of PET twin have asked questions, record, transcribe, and analyze each of these sections. With this material, people. So besides this transcript of the interview, we use this data source. So the ISO, IPI glossary of oil field, IPI water line operations, PetroWiki, SPA glossary, SLB oil field glossary, Wikipedia, and the list of technical tags that is used for monitoring production. So we collect this whole vocabulary. We are doing this job now. So now we have 3,021 entity, 321 entity, 174 continuants and 147 occurrents. And then the team realized the ontological analysis over the terminology. So most of terminology is process, equipment, physical access, material input, properties, and sites, region, and geospatial location. With this material, we start for term definition using ontological analysis, identify which are the rigid or independent entity, and then we provide a definition, a formal, a technical definition. We define the genus and the differential. I mean, this term, what is different from the more generical term, and we provide this for each one of these 300 terminology. And with this, we produce the specification, which is an O file based on BFO and some other ontologies. We use BFO, we use the standard of EOF, Industrial Ontology Foundry, we use Geocore, and then we produce the O3PO. Here we have a general view of this ontology, which are the terms of this one. For each of these terms, we have the formalized definition, the restriction, and the consistency through the reasoner, the basic reasoners that are available in Protégé. So with this, we have now an ontology network, which is a uniform view over this domain, all based on BFO. I can explain the choice of BFO, but this became the standard in industry now. But for doing ontological analysis, we still using UFO, the Unified Foundational Ontology produced by Giancarlo Guisardi and colleagues. But for specification, we do the specialization of BFO. Then we have the core ontology for geology, we have a core ontology for engineering, we have already defined the production plant equipment. For the reservoir, we have the deep marine deposit already defined, and then we have this ontology for figures and petroleum exploration. This tree that is here is available in our GitHub, you can download the O to take a look and the documentation of these ontologies. So that's general view. I am available for questions if you have, but what we know that's is a strong effort in developing ontology, is a tough work, but is rewarded by the effective reusability of the model. We have several applications we use for reducing the need of training sets for machine learning. We support interface, we support data analytic, visualization. So it's very useful when you have this vocabulary defined. So having a precise semantic help for algorithm extraction of tendencies, correlations, and patterns that sometimes is not possible to be done or is done using manual integration. So that's what I have for you today. That's the analogy of my today group.
Thank you very much, Mara, for this insightful talk. Very interesting, and a lot of knowledge that you are sharing with us that is very useful for the project and for all the attendees. So there is some questions. I don't know if guys you can show the questions on the screen, or I go through them. Uh, so we don't have a lot of time because we have next sessions in few minutes, but let me get one of the questions about standards. So we have a question about if your ontologies is aligned to any international standards of International Association of Oil and Gas Producers and so on. For standards existing for petroleum industry.
Yes, we have. The problem is that the standard is not aligned among them, but we use standards to do all the definition, and we try to align as much as possible to the standards. The standard that we use are listed for the petroleum plant as are listed here, not for reservoir area. But for reservoir, I myself am part for the HASCML group. I am strongly involved in the definition of the semantic of entity in HASCML standard. And for the geology, I am one of the people that are involved on this. Then we try hard to follow as much as possible the standard. But the standard themselves don't share the meaning of the entity. So say that I am aligned with all standard, it's impossible because they are not aligned between them. But the idea is to provide one definition, and that definition is explicit. Then you know if it's attached or not to the standard.
Okay, I have a question to complete that. I mean, concerning, I mean, that's great that your ontologies are aligned with BAFO, but in parallel, there is some initiatives under BAFO for industry, like Industrial Ontology Foundry. So I see that you have let's say, a mid-level ontology about engineering, so core ontology for engineering. So I would like to know if this work is aligned with IUF or not. If not, why you don't align with, because I know that IUF are creating IUF core ontology, including this part of engineering.
Yeah, we are aligned with IOF, as I show here, for the plant production, not for geology and exploration, because they don't have standard. Yes. And also, Nicolau especially participates on the group of IOF and bring the standards to the definition of the ontology. And also our adoption of BFO is exactly, I was in the meeting that BFO was chosen to be the standard for IOF, and then it's coherent of my side to attach to the decision that we have taken together.
That's great. Okay, right. So we don't have a lot of time. So I don't know if it is possible to let this session open and people who are interested to go to other sessions can start, but allow Mara to answer the questions here. So I don't know if you have access to the Q&A function. I see here, for example, a question about
knowledge graphs.
Yeah, there is a question about knowledge graphs.
Yeah, I can answer that. I myself don't use knowledge graph because of the type of application that we do. So we usually produce heavy ontology with strong definition, deep definition, restrictions attached to the model and the specification. In my view, knowledge graph is more useful when you do web search and you do integration. Maybe in the geodigital project, it would be more useful. Then it depends on the application that you do. When you are producing standards and support application, you need something more deeply defined than the knowledge graph usually does when producing. But answer this, I can tell that I myself don't use too much knowledge graph to be the right person to do evaluation about the utility of the has a modeling format or representation.
Okay, thank you very much. I just received a message that it is not possible technically to continue this session and
Okay.
start others, but we will keep these questions and keep in touch. All of those questions will be shared later and answers also for all.
I will move to the general
Yes, so
session, and then if people want to talk, they can call me in the session. I
okay.
appreciate and thank you very much for being here and
Thank
attending
you
this
for the
presentation
talk.
in the
Thank you very
interest
much,
of the projects.
and thank you all of attendees. So we can move to the other sessions. Thank you very much, and you keep in touch with Mara by chat. Okay, thank you.